So very good evening, everyone. Glad to welcome all of you to this special session. This is a special mentoring session done on behalf of Kyndryl and REVA University, brought to you because of the hackathon which is ongoing. So as you are aware that we have an excellent final set of solutions which has come in. And this webinar is in continuation of helping you to build the right product, the right prototype or MVP, so that you can actually see your models working in real time. And a lot of evaluation parameters is based on how have you architecting your end-to-end solution as part of plastic detection. Those who are new to this the webinar, because we have kept this webinar open, those who are new to the whole hackathon that which we are running on, please go to our website. Nikesh can put a chat on the window so that they can check what is happening. And this is in continuation of that hackathon. We have this grand finale coming in, and you would be evaluated based on how light, how efficient, how good is your end-to-end model, which the majority of the part is not just the model building, but also developing an end-to-end solution. So let us welcome specifically the subject matter expert and the leader from Kyndryl team. We are delighted to have you, Soumo Chakraborty. He comes with 17 plus years of diverse IT experience in implementing both at the strategic level as well as on the on the field level, and especially on the AI product deployment. And he works with various cloud partners and the entire MLOps cycle that he covers. And he comes with deep enterprise AI experience on leveraging various solutions in cloud as well as on-prem solutions. So the plan of action of today's is about an hour-long webinar that he will discuss today, how this whole 1 hour is going to be planned. And those who have been in the final 15 number list, right, in the evaluation list, please attend very carefully, because this is a single session where we would want Soumo to act as your mentor for architecting part of it, so that you can get the best practices and incorporate that in your solutions. And do share at the end of the sessions and your mentoring sessions a revised deck, which is part of the towards this. Along with Soumo, we are glad to invite both Shantanu and Debashish Panigrahi. Can we hear from them? Shantanu Nikam and Debashish Panigrahi. Both of you are there, right? They are online. So Soumo will be assisted by them. So we will have certain end of the question session. So please keep your questions coming on the chat window, and we can address them towards the end. So over to you, Soumo. Really looking forward to, because this is one of the most critical part of the solution building. And a lot of the people, though while they are excellent in model building, but creating a real working model is where the challenge is. So I'm hoping that this session will be very useful for all of them. Over to you, Soumo. Thank you.
Thanks, Dr. Shinu. Thanks, REVA University. I think the context is already set up. Excellent context. So with that, we will start the webinar. So let me share my slide, and then I will take you through. Can anyone confirm if my slide is visible? One confirmation is sufficient. Okay, good. Okay, good evening, everyone. Once again, I'm Soumo. So I work for Kyndryl, and I have an industry experience of around 17 years. And I come from so infrastructure background, and then moved to data, and then to ML and AI. So currently what I do is I'm from the solutions and architect team in Kyndryl, where we talk with clients, understand their requirements, get them the curated solutions on data and AI. And also I lead the development of MLOps on hyperscalers. And we have
Sir,
created.
sorry to disturb you, sir. But just we are not seeing your screen, sir. It's not visible, sir. Can you check from your side, sir?
Yeah, it's not visible.
Okay.
Maybe reshare.
Okay, I have shared it. Let me share it once again. Let me know if it is visible now.
Yes, it is
Yes,
visible
sir.
now.
Okay, let me do a full screen and it's still visible, right?
Yes, perfect.
Okay, sorry. Yeah, so that is what I do, and so I have a good industry experience around the solutions. And so today's webinar will be on a curated content from an industry point of view. How do we architect a solution, and before architecting a solution, what are the key challenges and what are the key approaches, and how do we finally converge into a solution? We will take you through the journey, and help me welcoming Debashish and Shantanu. They both work in the same team, and they are data scientists, and they also help with customer engagements for ML projects. So I think I have already covered my role and what I do. Let's get onto the agenda. So today's agenda is on three major topics. The first topic would be the architectural setup. How do you set up the architecture? So starting with the problem statement, approach, and what is a well-architected framework. The second part will be on the best practices that we see from an industry standpoint, and what have been we have been doing so far for our clients for our experiments on ML. And the third topic will be on MLOps. What is our reference architecture? I will go through a reference architecture, help you understand what we did there and the best practices associated with MLOps. And the fourth part will be the question answer session, where you can ask questions over a chat, or you can answer, or you can ask on this call itself, and we will try to assist you with the answers. So 15 minutes for each of the points, and let's get started. So yeah, as I told you before we even architect a solution, we have to understand the real pain point, right? So what we have seen always is ML project starts with a great intent, and over a period of time, the deviation starts happening either because of the data, either because of the cost, either because of the client's goal have changed. So with that said, ML projects are always very high expectational projects. So had it been a normal project, it wouldn't have been a ML project. It would have been any other project which could have been solved by a standard tool stack. So why ML? So that is where the ask comes into the picture, the problem statements comes into the picture, and we have to understand that what we are trying to do. So point one and point two predominantly addresses the challenges of the problem statement about the key ask, right? So whenever you start, so in context of hackathon or in context of a client, so what is the bigger picture and what is the end goal look like, right? So there has to be a target, there has to be a goal, and what should be that end goal? So is there anything associated with that end goal? Is there any dependencies? Is there anything else that the ask is for, right? And then the real problem, right? So understanding the problem is very, very important. Unless you understand a problem, you won't be able to create an architecture or even ideate an architecture to solve that problem. And even if you do that, you won't be able to reach to the solution. So I'll give you a small example here. So suppose you're working on a insurance industry, and the insurance and the ask from the business is, can we do a customer churn analysis? So while doing the customer churn analysis, we can also find out opportunities for upsell, cross sell. So these are the things can also be explored, found out by the help of collaboration and business understanding of the domain. So here this end goal matters because so every business wants to invest in ML, but they have to have a very clear understanding of the goal, and we should also have a clear understanding as well, and the real problem that we are trying to solve. The third point is again the vital point to start any project, the data readiness. So we talk about problems, we talk about our vision, right? But what about the data? So uh, we have to understand from a business context as well as from a technology context, the data that is available for doing this ML project, is that a consumable data? Can this data provide us the insights or provide us the solution that we are trying to intend for? So that validation is completely required before even we start this project, because unless you have a good data, you cannot have a good outcome. All right. The next point is about the tool stack. The tool stack and the resources. So when I talk about the resources, it could be the technical resources and it could be the headcounts as well, right? So I'll talk about the tool stack first. So tool stack here, choosing an optimal tool stack is of utmost important, because when you choose a tool stack, it comes along with skill, cost, and complexity. So I was experimenting with some projects a long time back on MLOps, and those projects were so it was on open source, and open source projects uh, are obviously having challenges because they evolve along with period of time, and we do not get any enterprise support, and and it has its own share of problems, right? So while we innovated the solution with open source tool stack, uh, and on the parallel track, we were trying to solve this problem with a vendor agnostic tool stack. So the agnostic tool stack is quite easy to maintain. It is quite easy to understand. It's quite easy to implement. And at the same time, it is expensive, right? And on the same time, when you start exploring on open source tool stack, they are quite easy on pocket. You don't have to invest much on them. If at all, you have to buy a enterprise support. So some providers offers enterprise support as well, but it has its own complexity, right? So understanding that tool stack that solves your problem is of utmost importance here. And the resources. So you have to also plan your resources, who can do what responsibilities, right? Because ML project essentially comprises of business understanding, data engineering, then ML expertise, also some expertise on DevOps. So essentially, there has to be a team who can do all this work at ease, and they can deliver the outcome, right? N- And then I go to the cost and the timeline. So cost and the timeline is again of business importance, because unless we understand the cost implication, understand we know the timeline, we won't be able to deliver it suitably as per the business requirement. So what generally happens is, what we have seen is, we factor a solution, but at the same time, we have to also understand the client's expectation or the project expectation from a cost standpoint. So certain solutions are very good in terms of the tool stack, in terms of the usage, but at the same time, the cost is exponentially high, because all ML projects consume a lot of resources, and they could be quite expensive at some point of time, right? So this cost is important, and along with the timelines. So you have to also understand a timeline, that while I mean, when you should be able to deliver the project in sprints or in water flow. So so this is a key parameter of doing a project successfully, and and a and and a viable project financially. The last point is the feedback. So feedback is again a key parameter here, because unless you know what has gone right and what has gone wrong, you won't be able to upgrade, or you won't be able to repair those parameters, right? So when I talk about feedback, there are two kind of feedbacks. One is feedback from the business, and the second is feedback from your model, or from your tool stack. The business feedback is important because you have to understand what you are doing is correct from a business standpoint, from a consumer standpoint, and and from a technical point of view, you also have to understand that the solution you have developed, the outcome you're getting, is it the one you wanted to get, or there is kind of a deviation. So so these are the six key parameters that I was able to articulate, and they are, again, as I mentioned, from a industry standpoint. So here is a typical flow of a ML project. I have bucketed into three functions. The first is the business function. So in the business function, understanding the business problem, goals and objective, cost and timeline is very, very important. So try to achieve this one whenever you are developing any solution for ML, because any solution that you develop on ML is uh, uh, it could be for a business problem, it could be for an industry. All right, so that should be aligned properly. The technical function is again, as you start the process, you start the experiment of the project. So the data, tool stack, approach, and solution, all four parameters has to align with each other so that you get an optimal outcome that can be accepted by the business. And the third is the delivery. So once you're sorted with business function and the technology stack or the technical function of it, then your delivery function comes into the picture, where you provide the outcome, the consumers start consuming the outcome of the uh, end goal. Suppose it's a classification problem, if they're able to identify the classifications correctly, then they're good with that. So so here the delivery function is important. Again, the feedback of the consumers, right? So you should have already heard about the feedback loop, how to generate feedback from the inference. So this feedback is very, very important, as well as the feedback from the business. And then we talk about optimization and scale. If all of this works in conjunction with each other, all good, then we talk about, okay, how can I optimize this good solution and scale it, right? So this talks about the problem statement. So if you have a question, you can paste it on the chat and we can take it down once we complete the agenda. Next, we'll move to the approach, right? So you have understood the problem statement, how to attack that problem. Now, how to build an approach, right? So there are two kind of approach, and I've used 10 points each to get you to build a good approach. So the first bucket is on the business approach, and the second approach is on the technical side. All right. So the business approach talks about the business challenges, as I was explaining. Understanding the business challenge is utmost important. Unless you know the bigger business challenge, you won't be able to solve the problem completely. It will be a partial solution of the problem. Understand the current environment. Now, when we talk about a challenge of a client or a hackathon or any other industry, so we talk about that what we have currently available. So is it the data? Is it the environment? Or is it the challenge itself, right? So again, if you're trying to solve this problem from an industry standpoint, you have to understand the client's architecture, the environment, how it is hosted, what data sources are available, what features I can consume from the data, and if I consume those features from the data, can it solve the problem, right? So understanding the current environment is of bigger importance, and we have to build an approach around it. Then the third point is the teams involved. So any ML project that we do, that we encounter, comprises of different teams. It cannot be solved by one person, or it cannot be solved by one single team. There has to be different teams from the client side, from the technical side, right? from the client side, you have to identify who are the teams. So there should be a team that manages the data. There should be a team, those are the consumers, and there should be a team who is driving this whole business, right? So there will be teams involved who will be giving you the business problem, providing you the data, providing you some approach how to solve that problem. So understanding the team is very, very important, right? And then comes the data source. So you have to build an approach how to consume the data from the data source. So if the data is available through API call, you have to understand what APIs can be used, how secure are those APIs, because whenever we are talking about data, it talks about different domains, right? It could be healthcare, it could be financial domain, it could be any other industry domain where data is stored in a secured manner, and the data also has to be consumed securely, right? So you have to understand about the data source, how to consume the data from the data source, and is that data good enough for your experiment. Then comes the cost and timeline. So cost and timelines is typically set by the business side, the cost along with the timeline. So every business understands that when this project has to be completed, and how much it takes for us to complete. So every industry or every client has a budget, right? Then you start proposing a solution. So start ideation with the client. If it is a hackathon, you can build a draft solution, share it with the stakeholders, understand their feedback, and again redraw the solution, right? The seventh one is a key important here, because we have to document whatever we are doing. So whatever we have understood from point 1 to point 6, you need to document. So document is kind of a discipline which it takes a long way, because unless you document, you won't understand that what you have gathered, what you are unable to gather, and what is that you're trying to articulate. All right. So documentation is utmost importance, because unless we document, we do not get the better picture, right? In architecting a solution, the documentation plays a very, very important role, right? The point 8 is the proof of concept. So while you have gathered the requirement, the solution, the cost timelines, everything, then you start with a proof of concept. Start small, start with small resources, and you- and get this solution validated by the consumers, by the stakeholders, right? And then you try to demonstrate the end state. So suppose if it is a classification problem, try to see if you're able to classify what has been asked for, right? So if it is suppose a regression problem, try to see if you are able to get the outcome as it is intended. So try to demonstrate the end state with the POC, so that you know you are aligned with the problem statement along with the solution, and get a business feedback. So do not perform any experiments, and don't conclude that yes, it is done, unless you get a business feedback. Because I told you as early also that ML is for the business, right? So unless you get that standpoint, that point of view from the business, it is incomplete still. Okay, let's move to the technical approach. So technical approach is again, once you're sorted with the business, then you start with the technical approach. So the data validation plays an important role as always, right? So without data, we cannot do anything much in ML. So you have to extract the data, transform the data, see the usefulness of the data, then try to do some feature engineering on the data and see what features uh, are you able to extract from, and are those features important, right? So derive a ETL strategy. You have to understand that how are you going to get this data from, and where are you going to get this data from. There are best practices around all of this. I will be sharing you in the upcoming slides. So this ETL strategy is important, right? Then you do the feature engineering. Feature engineering is, again, without feature engineering, you won't be able to extract those golden values from the data, those valuable information from the data, right? So try developing a feature store where you can store those features. It can be reused for offline inferencing, for online inferencing. So this feature store plays a key role when you're trying to architect a good solution, right? Then comes the training and the registry for the model. So while we start the training, the sizing of the compute becomes very, very important, because that's where the cost goes into, right? Your time and the cost goes into. So while we train, so there are several approach available for sizing. There are tools, and you can use your experience. And the best way is to start small, right? So start with a small compute, see, and you can execute the epochs and see how much time it is taking for this epoch to continue. If there is any resource challenge, if there is any error uh, so that you're encountering, right? So sizing plays a key role here, and then you train the model and you do hyperparameter tuning. You continue doing and until you get the best possible outcome. Once you get this outcome, store this in the registry, and that can be a reusable asset so for the experiment. Then comes the deployment and inference. So deployment inference, you have to strategize this once again, because for deployment you have to understand how it will be deployed. It will be containerized, it will be in an application, it will be integrated somewhere else on a IoT or edge device, right? So deployment also has to be properly approached and properly strategized. Inference is again important, because inference is something that the consumers will be experiencing, right? So inference, you have two options, either a batch inference or a real-time inference. So again, based on the business understanding, based on the business use case, what you are trying to do here, right? So how you're going to plan your inference. Observability takes a key part here, because after all, you build all these things, all this stack, and then you want to see how is it behaving in terms of the data, in terms of the KPIs. All right. So you have to build an observability dashboard or a observability stack on top of your inference deployment, your and your training framework, where you can see the real output of your KPIs, right? How much of the inference is working, how much of the inference is failing, what is the state of your CPU, your and the underlying resource. All right. Uh, so you have to build an observability stack. If you are working on an open source tool, open source tools comes with their observability stack. For example, Seldon, right? So Seldon has their own observability stack, where you have to configure the parameters and you can see those information in the dashboard, right? And all the cloud providers, for example, SageMaker, Vertex, they have their own observability stack, where you once you deploy your code on the endpoint, you will be able to see the observability if you enable it for, right? Then comes the triggers. So how do you detect your drift, decay, bias? So all these things comes at a stage where you have already deployed your entire stack, and you want to check for the drift and the decay and the bias, right? So you have to configure the thresholds for for all of these parameters, so that you're able to effectively understand that what is drifting, how it is drifting, and if it drifts, then what should be the action. All right. The same for the decay and the bias, right? And then the feedback loop. So feedback is again important here, because unless you get the real feedback, you won't be able to uh, take a call that you want to retrain a model, or you want to check the data again, you want to extract the features, or if there is anything going wrong, right? So feedback loops gives you a real-time opportunity from the users and from the applications, or a third-party integration, where you can integrate this feedback and check whether the stack is going good, or if there is any kind of an improvement required in this area, right? So let's move to the next slide. Here I'll be talking about a well-architected framework. So this architecture is from AWS well-architected framework. So you have understood the approach, how to build an approach for the underlying problems, and you also know of what are the key questions that has to be asked, that has to be gathered, and that has to be formulated before we start architecting a ML environment, right? So once you get all those ingredients for this architecture, then you can start building an architecture that shows you that how your data is coming in, how are you preparing your data, how are you training the data, deployment, observability, and this feedback loop along with some CI/CD pipelines, right? So so in a nutshell, the essence of a well-architected framework is basically on the standardization part, right? So if you're able to show the architecture, that means you have understood it and you have consumed the problem well, and you're able to standardize an architecture and show it. Then comes the scalability part. If you're able to develop an architecture that can be also scaled, right? And it will be a repeatable and a compliant activity so that it so that you understand that yes, this is what I wanted to achieve, and it has all the compliance, say IAM roles, policies, security, authentication, everything is in place, and it is a cost effective architecture, right? Because ultimately this architecture has to be validated uh, along with the business. So here in this architecture, what we see is uh, so we have a process layer of the data preparation and the process layer where you see the data is coming and we are able to pre-process the data, curate the data, and we are able to feature engineer the data, right? Once this feature engineering is completed, the features are stored in a feature store, and there could be two feature store depending upon the problem, right? And once this feature engineering is complete, then we start the training, hyperparameter tuning, evaluation of the model, right? And once we get the best possible outcome, we try to deploy that model on a deployment endpoint. Now again, you have to factorize, since it is AWS architecture, you will be able to see the AWS endpoints and other stuff. So in general, there has to be an endpoint or a gateway for deploying your a code, right? And once this model is deployed, the applications or the end users will be able to inference it so from the endpoint. So it will be hosted on a private or a public endpoint. It again it again depends on the problem statement and also on the architecture you're working on. And this deployment also should have an observability here, and this observability should show you the status or the health of your entire stack, right? So how it is going. And as I was talking about the triggers, it should have triggers where you key in some feedback. It should automatically start the training, or it should have some kind of a thresholds set based on the charts that we are seeing in the dashboard, that if the accuracy falls to a certain percentage, it should start that it should initiate the retraining. Or if I see there is any kind of a data drift, it should also start uh, uh, so pre-processing the data, curate the data, and it should extract the new features, right? And also I was talking about the registry, so the best model has to be kept in the registries so that it can be reused from a MLOps standpoint, and we will go into that, right? So that talks about a well-architected design, and every hyperscaler that you work with, it could be AWS, it could be GCP, it could be Azure. So they will have their well-architected framework. They will have a reference architecture where you will be able to take some kind of a reference, understand those architectures, try to do some small POCs and see if those architectures are really useful. But again, as we have seen from an industry standpoint, if we align with a well-architected framework, then the solution is really robust, scalable, as well as cost effective, because we don't end up using any unnecessary component that can incur cost, or it can increase the complexity of the project, right? So that is the essence of a well architected framework, and there are and every cloud provider, as I told you, has their uh, architecture kind of reference in their sites, so you can start exploring them and build your hackathon solution. If it is a open source, also open source has several sites. So I was talking about Seldon, then you have ODH, which is the Open Data Hub, and these sites can provide you a lot of in-depth understanding of the well architected frameworks available. I have seen one hand. Do we want to take those questions now, or we can park it for the end of the discussion?
Let's take it in the end, Soumo.
Okay, sure. So we'll come back. Okay, let's talk about some best practices quickly. And we have to be mindful about the time as well. So this is the stakeholder story, right? The stakeholder story is quite interesting, and it gives a in-depth understanding of how an industry works, right? So here there are three personas, or three category of personas. So one is the CXO, the other is the technical team, the core tech team, and the other one is the chief data officer. So we will see from a CXO standpoint, what are the top needs and challenges, right? So, so from a CXO standpoint, or this CXO can be replaced with a project director, or someone who has given the project, right? So for them, it is like a slowness of the project. They want to increase the profitability margins. For them, automation is of utmost importance, and these are the challenges that they face in a uh, in a business or in a project, right? And the top requirements are this solution and whatever solution we are thinking, it should have an end-to-end governance, end-to-end automation, and the key outcome should be the code should be brought to the production faster. So for them, as you see, they don't care about the architecture you're using, the code you're using, how efficient is the code. For them, the ease, the fastness, the economic viability is very, very important than anything else, right? Here is a tech team who are into data engineering, data science. For them, they want to do experiments on a centralized platform. They don't want to do it in their laptop. Skill remains a challenge because they have to do several activity, and skill is a key constraint for them. And they are also challenged with the reproducibility, scalability, automation, and security of the project, because they somehow didn't explore all these avenues, right? And the top requirements are uh, so they want to consume, or they want to do this experiment on a high compute platform that can provide the compute as and when required, and they want to use this experiment on a secure platform with a high capability performance, and they also want to do some automation so that the feedback goes faster, the training happens faster, and the AutoML is also a point where they want to utilize, right? And the chief data officer is bothered about the data and privacy. He doesn't care about the cost, because the data cannot be compromised with the cost, right? So, so even if it is an expensive solution, if the data is protected, for him, the data is of utmost importance, right? So the challenges here are the data privacy. So Ron wants the data privacy, the security, the compliance. It has to be of utmost standard. It cannot be compromised, it cannot be hacked, it cannot be leaked. the audit trackability, the traceability is very, very important, because he has to know where this data is coming from, where it is going, who has consumed the data, and what is this data used for, right? And the top requirements are, this governance has to be eased out, right? It has to be eased out. The tracking has to be eased. It should be easy to understand governance in terms of data, and it should also help the audit purpose, right? So this data should be auditable, and it can be auditable at any point of time. So now you have got a very broad understanding on what the industry requires based on the individual category of users, right? So if it is a business, it's a top business shot who is running the industry. For them, the priority is completely different. If it is a tech team, here the priority is completely different, and it is focused only on the technology stack, the ease, the automation, and the scaling, right? And for the and for the data officer, or who is in charge of the corporate data, they are only bothered about the way this data is consumed, the way this data is protected, right? So I wanted to bring the stakeholder stories so that you understand, you appreciate that it is just not the ML problem. It is a problem that is seen differently from different stakeholders in the industry. And in case of hackathon also, it will be very, very important, because there will be juries who will be seeing the business problem from a different angle. You guys will be developing the solution, understanding the approach, and whatever the so the points I have already mentioned, I've shared, and there will be juries who will be seeing, okay, if the compliance has been met, if the if the data has been securely consumed, if the tool stack has been properly used, has the governance been applied. So all these things can also be checked. So just think through from all this category of users who will be reviewing the solutions, either in an industry or in hackathon. Let's go to the best practice slide. So the best practice slide is slightly exhaustive, but again important at the same time. So I'll start quickly with the data ingestion. So in data ingestion, as we know, the data is the key, right? Without a good data, or without a good engineered data, we cannot achieve the outcome. So data identification is important, as so you have to identify what data am I going to use, right? And then the ETL part of it comes into the picture, how I'm going to consume the data. Data annotation is important, because that is how you are going to segregate your training and the testing data set. Also your validation data set if it is required. Then the data privacy and security. So as I told you, data just cannot be used. You have to have control over the data. This data has to be consumed in a secured way if it is an industry specific problem. Then feature engineering comes into the picture, where you capture the relevant information and build a feature store if possible. Then comes the data backup and the recovery, because the data has to be kept somewhere after you feature engineered the the data. If the data is lost, that is again a rework, right? So this data has to be backed up, and it also has to be recovered. It should be a recoverable data at any point of time in case it is required for, right? And then we do the pipeline and versioning, so that if it becomes an easy task for us to consume the data. And we also know, okay, this data set has been versioned 1. I have changed certain parameters, or I have transformed this data set into a different data set, and I will be keeping it as version 2, so that we have a proper tagging of the data, and we also know which data version has to be used when, right? It gives us the complete flexibility and clarity on the data part, right? Then we come to the model build part. So building a code is easy, but building a essential code that will solve a problem is important here, right? So domain understanding is very, very important here. So try to understand what domain you're trying to solve a problem. So in this hackathon, I believe it's an image recognition problem. So where so we are trying to understand the plastics, right? So here, if you have some domain information, or if you have some kind of an idea about this domain of sustainability, then I think you can build an excellent use case along with other features that can help you to solve the problem better, and you can uniquely stand in this competition, right? Then comes the feature selection. The features selection is important because you have to extract the features that is important for your training, right? And then comes the algo selections and the KPIs. So algo selection is again start simple and then go complex, and KPIs are also important because these KPIs will help you in the observability stack, right? So these are the KPIs you want to track in the observability metric. Then comes the code repo. So you want to, of course, save this code onto a centralized repository like a GitHub or a GitLab or your enterprise, any enterprise code repo. You don't want to keep this code in a laptop so that it is easily confused, lost, or it cannot be shared. And then comes the documentation. So documentation in the code, documentation alongside, if you do on on a separate document file, that will take this solution, or that will take any solution, I mean, beyond the value, because it is very, very essential. You document and you explain your stakeholders what is this code doing, what are those KPIs, where you're saving the code, right? So at every stage, I have added a documentation. So training part, again, sizing the compute is very, very important because this is where your cost goes and your time goes as well. So start small again, see the epochs, see the outcome, and then go uh, ahead. And there are tools available, and all hyperscalers, all cloud providers have their own set of tools and pricing. You can check that out and see how much the cost is, and the ultimate target for any use case, irrespective of industry or hackathon, is building a cost effective solution, right? Then splitting the data set, right? While you are uh, so performing the training, then you have to split the data set and see how optimally you can split your data set, whatever overall data has been given to you. Then the hyperparameter tuning. So you have to tune your hyperparameters and again document those hyperparameters and why you have used those hyperparameters, right? So every point that I'm talking out should have some kind of a reasoning, some kind of an in-depth understanding, so that whoever is reviewing the solution, it could be a business, it could be a jury, understand that yes, this is why you have used this, right? Then you can create training pipelines so that we can track the failures, or if it has gone good, then if you want to take the same pipeline, and if you want to reiterate that experiment, and at the end of it comes the documentation. All right, so we'll start with the model deploy. So again, so deployment has its own approach, right? So you have to choose the platform here. Where are you going to deploy? Is it going to be on an on-premise environment or a cloud? Then comes the scaling part of it. So scaling is again the containerization. So the best possible way to scale is containerization. And if you're using a cloud native solution, then try to use the auto scale feature. So all the cloud providers have an auto scale, all your endpoints can auto scale, but again, that comes with a cost. So see of that what endpoints are being used and what is the compute of that endpoint, how many users are going to consume that solution, and what is the cost, underlying cost for it. So you should not overutilize the compute or underutilize the compute, right? Then the API designs, right? So API designs has to be documented well so that it can be reused by any third-party application, any user or any application on premise. So API has to be completely, it has to be well architected and well documented as well. Then the update strategy also has to be defined, because you have to know that when this code can be trained or updated, right? So suppose so a small example is Amazon, right? So Amazon, so the recommendation that you're getting now, and probably on a festival sale, it will be different, because the festival will have several products at a cheaper price, and those products will also be recommended to you based on your I mean purchase history. And the products you're seeing now, probably it will be it will be based on your current purchase history, or based on what price you have bought that products for. I mean the other products you have bought for. So this requires some strategy that when my model should change, when a model has to be retrained. And again, at the same time, documentation. So API has to be documented. The platform, the scaling containerized solution has to be well documented so that we know that what architecture is being used and why it has been used and what is the steps aligned. So aligned with the documentation for the deployment stage, right? And you can also add a feedback or a UAT. UAT is user acceptance test, where a user or a consumer uses this solution and sees for the outcome, and is that outcome aligned with what is expected, right? Then comes the observability and the inference. So again, the strategy is important. How this how this inference will be done. It will be done over a real time or a batch. The caching is really important from an industry standpoint, because we try to inference the same data again and again. If there is a caching included, it will help us to reduce the time, and it will also help us to reduce the load on the inference architecture or the inference endpoint, right? If it's cached properly. Auto validation, you can also do some auto validation where you can run some scripts for checking the output and create a threshold. If you see that outcome is not up to the thresholds, you can initiate a retraining, or it can be a human driven activity as well, right? And then comes the baselining the KPIs. So from the build stage, you have already validated the KPIs, and here you can see, are those KPIs baselined properly? Are those KPIs getting captured on the dashboard, right? Then the triggers comes into the picture, where you configure the retraining of your code, and if there is any data drift, if there is any kind of a drift or a decay in the model, you can initiate a retraining. And at the end of the stack, you have to also document your KPIs, your trigger configs. Why did you do? If there is any caching implemented, so you have to define and also try to incorporate this in your architecture, right? So it is quite an exhaustive but useful from an industry standpoint, and from a practicality point of view whenever you're designing any solution for ML. Let's go to the MLOps side quickly. So this is the MLOps architecture. So MLOps architecture is an orchestrated architecture, automatic and orchestrated architecture for whatever you have built until now, right? So here you can see a data layer, and this is SageMaker. So SageMaker is used to so it is basically the ML platform that you're using, right? And it is a hybrid platform we are trying to show here. So hybrid in the sense you can either use SageMaker, or either you can use a Kubeflow. So so for the sake of understanding the hybrid architecture, I'll go through the Kubeflow stack. So here we have implemented Kubeflow, and it has its own workbench and training ecosystem. And we are consuming the data from the data sources, ingesting into Kubeflow. It can be into an S3 bucket as well, and we are curating the data, starting the training, and then we are initiating the KF pipelines or the Argo pipelines. And it will basically train, and we can hyperparameter tune it and store the best possible code in ECR. So as I told you, it's a hybrid. So here we are using some some components of AWS and some components of the open source on premise on EKS. Then once your best code is registered in the ECR, so Elastic Container Registry, then what you do is you deploy this code on a Seldon endpoint. And once this code is deployed on Seldon, we also expose the KPIs. So Grafana and Prometheus are being used as a observability stack here, and this will keep an observability on the endpoint. And once there is any drift detected, it will initiate a AWS code pipeline. And this code pipeline will take care of the automatic training, or automatic retraining. If there is any drift in the data, it will also take care, right? So this is what MLOps on hybrid is like, but MLOps is again a deeper subject. So I wanted to give you a gist of it so that you understand that you can also use a hybrid way of using MLOps or a cloud native way as well, right? And then the last part of it is the MLOps best practices. So again, from an industry standpoint, the conventions that you choose for the names are important, because these pipelines, these CI/CD codes, or the CI/CD pipelines, even they has to be properly it has to be properly named and articulated, so that anyone who uses this platform understands the essence of the names, right? Then the data validation is again important, as we all know now. So experiment and trackability of those experiments are important, because these experiments can fail, or it can or it can or it can provide some of the results, and these results are required for tracking, so that it can be reiterated, right? So you can implement some code checks as well. There are so several tools available for code checks. So code checks is a good way to commit the code even before you yes yeah, so you try to commit the code, it can be done, and it also gives a sanity check over the code that we have already written, and it is an industry compliant process as well, right? And then the validation across segment, you do a validation of your model. Then comes the utilization and the scaling. So you have to so you have to be careful about how much the so the scaling part is important, because the scaling is based on the compute, right? And the compute should not be overutilized, and it should not be underutilized. It should be optimally utilized. And if it is an optimal utilization of the compute in the deployment process, so it will help you to save your cost as well, right? And then comes the predictive service performance. So if you have some kind of observability, so here what we're trying to say here is the observability, right? So you have to keep an eye of of the service, the health of the infrastructure, right? If the health is well, if the health is going good, then you can perform your experiment and the outcome can be achieved easily. Otherwise, again, you have to re-architect the architecture, and you have to bring in some more components, and again it will be a time consuming it will be an exercise, and also it will be a cost intensive exercise. So uh, so be careful about this, and try to incorporate a health observability infrastructure. And the choice of ML platform, because as I told you, there are several ML platforms out there. You have to choose what best suits the purpose, right? the the collaboration and feedback is equally important, because until you get the collaboration and the feedback so from the business team, from the consumers, you won't be able to understand whether the solution is good, viable, or it requires some kind of an improvement. And score your ML systems, right? So we have to score for the accuracy, and we have to score for the drift, and we have to understand that I mean, for whatever output we are getting from the code, is that I mean, what we are asking for, or it has to change over a period of time, or if there is anything else that has to be done, all right? And the last point is about the automation of CI/CD and continuous training CT that can be triggered based on the threshold values, right? So the CI/CD and the CT part is again an advanced component, and again a scalable component, right? So you can choose it based on again the requirement. So if it is a one-time use case, you don't have to choose it. If it is kind of a repetitive experiment where uh, the retraining is important, and you have to retrain, you have to check for the data drift, you have to check for the bias, if you have to check for any other parameter that deviates over a period of time, that has to be taken care. And that is how we build the MLOps platform, right? So these are the some of the best practices, industry curated practices I was able to share with you folks. I think that's all from our agenda standpoint. I think we have gone a bit more. Um I think we can open up for questions if there is anything else we can also discuss.
I think there is a hand which was raised from the beginning. We will see that if the hand is, I think, Pavan, right? Who was it? Or it was by mistake. Okay, Krishna. Okay, please go ahead, Krishna.
I think Krishna is on mute.
You can speak now.
Hi everyone. Yes, I am able to talk now. So the question is, if the source data is in form of images, how do we measure the data drift?
Okay, a good question. Krishna, apart from Krishna, anyone else has this question? Okay.
Sarthak. Yes.
So I think Sarthak also has the similar question, right?
Yes.
Okay. Okay, great. So I would invite Debashish to address this question for you both. Debashish or Shantanu, any one of you.
Yeah, you can see Debashish.
Yeah, hi. Good evening, everyone. Thanks, Somo. That was a great session. So to answer the question, basically we need to understand what is data drift, right? When there is a change in the data for which our model has been trained, right? At that time, there are two types of either it can be a change in data or change in content, right? So coming to the images, basically our images will be static, but in some of the cases we can have augmented images, right? Just the the augmented part of the image. So in that case, if we have augmented data, then we may need to train the model again with the new augmented set of data. So basically for the images also the same theory applies.
Krishna,
So
hope that answered.
No. So I mean, it was more on the basis that what was the parameter I can observe on the basis of that which I can trigger a retraining. I mean, what kind of drifts I can measure for the source image type of data?
I think this is a very tricky question, Krishna. See, we have this plastic data which, Krishna, are you with race, right?
Yes, Dr.
Yes.
Shin, yes.
Okay. So the images in this use case, if you see, it is plastic thrown around in the water, right? Even if you are augmenting or even if you are using the same data, we are assuming that you are not bringing some other data without plastic. Even if that is the case, the model will not be able to detect, right? So the data drift, usually this happens mostly on a structured data than image is in our experience. So I'm sure Devashish and all has better answers, right?
Yeah, that's correct, Dr. Shenu. When we have this structured data, there is a high possibility of getting changed data over a period of time, right? But when we have this image data, right, which basically captured through drone and all these things, they are not going to change over a period of time. If it is changing, then it will be a new incoming data for us. It is not the same data which got changed.
And the model anyway will fail. So you need to really look
Exactly.
at, yeah. Yes.
Yeah, I think the outcome is important here. So outcome will tell that whether the data is good for the inference or not.
Anyone from the team also can answer. If you think that there is a better answer, somebody has seen a real data drift in image-based use cases, please, no, you can answer. But in our understanding or experience, I think it's very rare that instead of say plastic image, face, somebody's facial images come down. No? I think that is very, very rare. And if that happens, then the model efficiency will come down, and that needs to be
Absolutely.
checked. Yeah.
Right.
Absolutely, yeah.
That itself is a trigger.
Exactly.
Yes. Krishna?
Yeah, Dr. Shinu, so that really answers my question. That was more or less based on my caption also, which was on a very similar grounds of images. So
Yes.
you know the context. One more question I have, but it's a general question. In general, if we see that the model is very stable, though in that case, how long we should be ideally waiting before triggering a model retrain from our own side? I mean, is there any such rule ever set in the production that if we are not observing any data drift and all, but still we do trigger a retrain after some time? So in that case, if that is going to happen, then what's the time period?
Okay, basically it depends. Okay, for it varies from project to project. What happens is on a continuous way, right? In a timely fashion, we are monitoring the performance of the model on it. I say whether it will be a weekly or bi-weekly basis. We are doing the performance, how the model is performing over a period of time. Okay, so after 6 months, you have not reached the threshold where the model accuracy or say any measures, right? That got drastically down beyond the threshold value which was set during the business discussion. So in that case, I don't think so. We need to go for a trigger or something like that because your model is performing well, and that gives an indication that whether it is a new data for which the prediction is being done, it is more or less same from the past historical information. So based on the performance measure over the timely manner, we can be sure that okay, there is no need of retraining the models. It is still it is doing good. So if you ask me what is there any specific time, I don't think so there is any specific time after which we need to retrain it unless and until the performance of the model is deteriorated over a period of time.
Thank you. That answers my question and answers my curiosity also. Thank you.
So Krishna, again, the outcome, right? So based on the outcome, what you're seeing.
Yeah.
Yep.
Okay, I think there are some questions on the chat. Pavan says that Azure as the hyperscaler, do we have any preference towards that from Kyndryl or any other preferred cloud?
I think we don't have any hyperscaler preference, hyperscaler alignment. So I think the solution that the innovation that you will be bringing in the solution and based on the best practices shared, I think so that will score then the platform itself.
So I think just to reiterate, we would not look at proprietary expensive resources since this is a hackathon. We would want to solve the plastic problem in a very environmental friendly way, right? So please be mindful on the cost and the brand, etc. That is not what the judges would look at.
Right.
Okay. AWS, same answer, so nothing particular. A few of them are building their own. So from the point of view of ours, we have all the solutions now, but some of them have really worked on building a tool agnostic platform, which is really interesting. Okay. Yeah. Any specific questions? Anyone?
Ma'am, there are two people who has raised hand, ma'am.
Oh,
Ijaz
okay.
and Ravi Kumar.
Yeah. I think Ijaz's question is on AWS, or is there any other question?
Good evening.
Good evening.
I have a simple question. I'm new to this architect AI solutions. How can I browse and scale the database? How to deploy the model? Can you summarize in few words? That's my simple question.
Okay, Somo, did you get it?
Yeah,
it is
he was
difficult to
telling
hear.
about browsing the database and scale the model.
Is it
Is that
correct?
Yes.
yeah? Okay, so browsing the database, Ijaz, it depends where the data is, right? So if it is a say if it's a SQL, so again the data type, right? For data type we are checking for. So if it's a structured data on a SQL database, you can use a SQL query, right? If it is on a non-structured data, unstructured data, so accordingly you have to fetch the data. And scaling the model, I told you about, containerization is the way to scale your models. And if you're using any hyper scalers like Azure, AWS, anything like that of sort, then you have auto scaling for your endpoints. So that's how you should be ideally able to scale your model. Hope that answers, Ijaz.
Yes.
Thank you.
Yes, I clear. I have another question. Can I ask you?
Yeah, please.
Can as you said, MLOps in AWS model, can it be architected using AWS? Is there any other platforms which is so user friendly to scaling data model and deploy model, and it also to be documentation?
Okay, if I have understood your question, Ijaz, you wanted to know an alternative to AWS that can do MLOps. Is that your
Yes,
question?
yes.
Okay, yeah, there are a lot, right? So Google has Vertex, then MS has Azure ML Studio, and then you can go to open source market like Kubeflow. So Kubeflow is a great tool. Then MLflow is also there. So there are a lot. So again, so you have to fall into the best practice and see what is your use case, how big or small it is, how much cost can be spent for that project, and who are the end users who will be receiving it, right? So yeah, so there are alternative platforms than AWS SageMaker that can do MLOps.
Okay. Thank you, sir. Thank you for your kind answers.
Thanks.
Nikesh, Ravi has a question here.
Yeah, hi everyone. Good afternoon. Yeah, so regarding, I think Ejaz asked that question, so which I had. So is it specific to AWS, which we are doing the MLOps architecture, or any other cloud dependent, or even on-prem, we have the option? Just wanted to check.
Yeah, Ravi. Good question, Ravi. So MLOps is a capability, right? So it's a capability development on top of the stack you have already built. So you can consider MLOps as similar to DevOps in SDLC, right? So MLOps can be orchestrated. So MLOps basically is a concept and set of practices. So if you can inculcate, or if you can incorporate those practices of automatic training, how the data pipeline can flow automatically based on certain thresholds. If the observability stack shows an anomaly, how that anomaly can be fed as a feedback and it can start the retraining. So this practice is incorporated in tool, right? So it can be AWS, it can be anything else. Yes. So in short, the answer is yes, this capability can be developed, even as I told you, in open source tools as well. Yeah. Hope that clarifies, Ravi.
Yeah, it's clear. Thank you. One more question I had with the first slide, like regarding the business requirement and business approach. So for example, if we build a system or do a architecture, like going back to the business for feedback, it's like end customer or within the organization whom we will be approaching for the suggestion or feedback, whatever model we have built.
Yeah, I think great question, Ravi. Yeah, so to identify who will be giving a feedback is always a challenge, right? So the business gives the business problem. And so ideally, so what we do again from industry standpoint is we have to ask that who will be the end users, or can I get a subset of end users who can try out my POC output or my POC inference. So ideally, this should come from business saying that, okay, I can give you a subset of users who will be consuming the inference or the solution and provide your feedback. If that cannot be achieved, then what we generally do is we try our own solution, document the output, show it with the business. If they are in agreement, we go ahead. Otherwise, we again change and start as per the feedback.
Okay.
So
Okay,
the answer
thank
is
you.
it depends on the business. Yeah.
Got it. Thank you.
Thanks.
Any other questions? Anyone?
Ma'am, we have a question in chat, ma'am.
Okay. ML architecture about how the prototype is built using certain MLOps services will be an evaluation criteria. Yes. So there is about 25%. Sarthak, there is a mail which has come from us while you met the mentor. So please check the different parameters we will use for evaluation. A working prototype and the architecture is part of this evaluation. So please be mindful on how are you showing your model, right? How and third party will use your model. It cannot be sitting on your laptop. Yeah, of course, Soumo, please answer.
Yeah.
That is an evaluation criteria, but
right. So to add, Dr. Shinu, so your experiment or whatever prototype you build, that should be a scalable prototype. Right. So that should be a scalable prototype, cost effective. And why are you using those components? That also has to be quantified and justified in the form of documentation. So ensure what you use, you know why you are using and why not the other ones. And when you use, ensure that this can be a repeatable exercise, a scalable exercise, right? So that's the gist of the objective for this hackathon. Hope that answers.
any other questions, Nikesh?
No, ma'am. Ma'am, just now we have got another question, ma'am.
Okay. Render for easier deployment. Okay. Have you heard, Somo? They are saying that traditional deployment models we are not comfortable, but we heard new tools like Render for easier deployment. And there is a link also he has shared. So this question is from Manav. Manav is one of the finalists. Manav,
Okay.
you can speak up. It will be good. Because the market is flooded with tools.
Right.
You can speak up, Manav.
Yes, ma'am. I'll give you the access to Manav, ma'am.
Yes. If everything comes with no certain payments and all that, please be mindful because you also have to set it up with a paid account, right? Even to demonstrate.
Hello.
Because some of them being students, you have to be aware about this. Manav, are you speaking up?
Yes, ma'am. So I have not much. I have not got much experience with deployment tools. But tools like Heroku, Render, they all offer like one-click deployment. So is it fine if we use that solution?
So Manav, one-click deployment of what? I mean, what is that you're going to achieve with this tool?
So I have my backend in Fast API, and I can like upload my code on GitHub and connect my GitHub repo with these tools, and can easily deploy.
Okay, and this deployment will have a UI as well as an endpoint. And from the endpoint, I mean from the UI, I'll be able to inference the endpoint.
Yes.
Is okay. Okay, I never heard of this tool. I don't know if Debashish also has
Yep.
heard of.
So this render, I don't think so. It's a open source one. There is a cost comes with this render deployment, right?
Yes, they have paid plans too.
Yeah. So why Kubernetes, or rather we are going with open sources, it's for scalability as well as it is an open source, right? So industry, when it comes for industry, I agree that we can use render for deployment, but when it comes to cost, right, it will be an extra burden for the client, or say for whoever you are doing the project for. Okay, because this cost will be goes on you know in an incremental way, because today if you are using say 1 GB of data, tomorrow again your data size getting increased, right? At that time you have to increase your resources, so this cost will be play a major role as well. So that's the reason why most of the client prefer to go with the uh, available open source stuffs. I mean, we can use render for deployment. That is not a burden, but yes, even if the same functionality you can get in other deployable tools as well, which are open source basically.
Okay, thank you.
Yeah, I think they are coming from a student's perspective because they may not have AWS access or Azure access. From an academic credit point of view, you may use Azure if you have EDU account. Please check with your team from the university. They will be able to help you. But you can use any tool, Manav. We are.
Okay, thank you.
So here the essence is cost and scalability. So I mean,
Yes.
whatever you choose, be careful about these two important factors.
I mean, see, to add one more point is render, I think for practicing purpose and for student account, it is free. But when it comes for real-time deployment, right, I don't think so it is preferable because there is a cost associated with it. Yeah.
Right. Right. Thanks, Devashish. Is there any other questions, Dr. Shenu?
Yeah, I think if anyone has any questions, please speak up. Otherwise, we will kind of conclude the session. I'm just putting on the video mode. So at the outset, Soumo, thank you so much. It has been very, very useful. I think your storytelling is really nice, from business problem statement to the entire architectural deck, and also bringing out the persona of understanding stakeholders need very clearly. I think if you could address, because people like Soumo comes with 17 years of experience. So he has already learned the hard lessons through his daily experience of dealing with clients, right? So those who are approaching the hackathon finale now, if you could bring in these kind of understanding of the different stakeholders, than just telling about, say, efficiency of the model is very critical, but how do we tell a good story and convince the judges that among all the other solutions available in the market, your solution matters because you address the real pain point of at least important key stakeholders. I think if you can tell the story, that is excellent with the working model. So please don't underestimate the working model and only talk about the story, then the story will fall flat. but have a good product, but wrap it up with a great story. I think that would help. So, Debashish, Shantanu, I think you have been there with us throughout the journey, and it's been excellent learning even for us, right? It's a very different set of hackathon that we have put compared to what is there in the market. There is no ready-made solutions here. Everyone has brought in very ingenious solutions, and Soumo, this session especially because this is kind of make or break evaluation parameter, how to build an end-to-end solution. So this was really helpful, right? So thank you so much. And the team, everyone here, please know that we are organizing this grand finale, the grand hackathon. So Soumo, if you don't mind, I'm going to quickly share the screen and take them through that grand finale thing so that everybody is aware, right? So yeah, so our team can please put this on the on the chat. So we have this grand finale. So this has been a phenomenal journey for us, starting from 720 teams, and now we are looking at 15 shortlisted participants presenting 10 to 15 minutes of their solution to a panel of expert judges, and we will shortlist 5 who will walk away with tons of money and so many different swags, etc. So this whole event is about 4 hours event. We are planning it on September 8th. It is in Bangalore, Chanakya Auditorium, REVA University, with a lot of interesting things. So it's not just 15 teams presenting, but we also have a great set of leaders, Kyndryl senior leadership team, REVA team, plus a series of industry participants also would be there, and a good set of learning how to make an AI solution out of especially these kind of random problem statements, but very, very critical for our environment. So we look forward to meeting all of you. Please go to this page and register yourself. Please bring your friends along. And we also have promised great entertainment as well as good food along with good learning, right? So looking forward to meet you all. And again, a big thank you to Soumo for having planned this whole session, though it is very, very heavy on the content side. You did a fabulous job of simplifying all the important information. Soumo is available, I'm sure, in LinkedIn and everywhere else. If any team wants to connect to Soumo and talk about architecture, please do. He's one of our key mentor in architecting. So please connect, or you connect through us. We can connect through Soumo. This is mainly for the finalist of the hackathon. So with that, let's say that let's continue learn, continue solve problems. With technologies, without technologies, but problem solving is the key. Let's go ahead and make this place a better place. Keep learning. Thank you so much, Soumo and everyone. Thank you, Debashish. Thank you, Shantanu.